You have to read a 220-page book. It takes you 15 minutes to read 10 pages. About how long will it take you to read the entire book? That is what we need to answer. About how long it's going to take us. So let's answer that. It will take us blank. Now my label here, they're using minutes above. So we can write that, but we might end up changing that. It will take us blank minutes to read the book. Let's find what values are being related. You have to read a 220-page book. It takes you 15 minutes to read 10 pages. There's a relationship right there. Now, minutes should go on the bottom because it's referring to time. That means pages needs to go on the top. 10 pages for every 15 minutes. About how long is referring to minutes. So that's our variable, right? I'm going to put an X in the minute spot. Will it take you to read the entire book? We know how long the entire book is. It's 220 pages. We are ready to solve. Do you see a horizontal relationship? Yeah, 10 times 22 is going to give me 220. So we have 10 times 22. Let's take 15 and times that by 22. That's going to tell us how many minutes. What do you get when you take 15 times 22? I get 330. It will take us 330 minutes to read the book. Now, if you ask me, I would not describe how long it took me to read a book in minutes if it was this many. We can use a bigger measurement to describe that. So let's take this just a step further, just for fun here. And let's go. We know that there are 60 minutes that equal 1 hour, right? So let's change the minutes it takes to read the book into how many hours that is. What would we take 330 and divide it by? 60. We want to know how many groups of 60 go into that. So take 330 divided by 60. What do you get? 5.5. So 5.5 hours. Or you could say about 6. Right? It's going to take me 330 minutes to read the book. It's going to take me 5.5 hours to read the book, or it's going to take me about 6 hours to read the book. We'll leave it as 330 in our answer here, but just recognizing that that would not be something that we would really say. We would describe it, since it's a larger amount of minutes, we would describe it using a larger measurement, which would be hours. Let's go to the next example. Here's example 3. A scale on a map is 5 inches to 7 miles. How many miles are represented by 12 inches? What are we being asked to find in this problem? How many miles are represented by 12 inches? So blank miles are equal to 12 inches on the map. Scales on maps are really nice because they take long distances and condense it down to just a single page or a couple pages. So they're really helpful. Let's go line by line, look for those relationships, so those important numbers. A scale on a map is 5 inches to 7 miles. So 5 inches on the map is equal to 7 miles in real life. That's what that means. How many miles are represented by 12 inches? So we know that miles here is going to be our X, and there's our 12 inches. I don't have a lot of space. I'll go like this though. That's our X. We have inches on a map, so let's let inches be on top and miles be on the bottom. And if you didn't think about inches on the top, that's fine. Have miles on the top, inches on the bottom. But we have to be consistent in our second ratio over here. So let's write our given rate out. It's 5 inches for every 7 miles. How many miles, that's our X, remember, is represented by 12 inches on the map? Do you see a horizontal relationship? Do you see a vertical relationship, top down or down up? Here's where we're going to take an opportunity to use our cross products. Let's start by going 7 times 12. And then we're going to divide that by 5 to find our missing value for x. What is that? 16.8. Yes. So 16.8. X equals 16.8. That's 16.8 miles are equal to 12 inches on the map. And we solved this proportion using cross products. Here's example 4. For every $9 that Frances makes, she spends $7. The rest goes into her savings account. If her weekly take-home pay is $540, how much does she save each week? We're being asked to find how much she saves each week. So let's answer that. She saves blank money each week. This is an E. Let's look for those relationships above. We know that for every $9 that she makes, she spends $7. So 9 that she makes, she spends 7. There we go. The rest goes into her savings. Oh, do we know what the number is? No, we got to figure it out. So we know she makes 9, but she spends 7. So I would subtract, right? How much goes into her savings? 2. So that represents savings. Ah, good to know. If her weekly take-home pay is $540, how much does she save each week? That's what we're solving for. That needs to be our X. That has to be one of the labels in my proportion. So let's have that go on the top. This is going to represent what she saves. And what is that being related to? What she makes. So we're going to find that relationship between what she saves to what she makes. So let's figure out what's going to go on the top here in my first ratio. For every $9 that she makes, 9 is what she makes, that's going to go on the bottom. She spends 7. Is 7 going to go anywhere in there? No, it's not. So what am I going to put in the top value here that connects to these values that are in the first sentence? Well, we know that when she makes 9, she spends 7. That means $2 is going into savings. So I'm going to relate $2 in savings to every $9 that she makes. We're trying to figure out how much she'll save if she makes $540. All right, we got our proportion set up, and this one was a little tricky because we weren't given the exact value here for our numerator. We had to use the relationship in the first sentence to find that. Do you see a horizontal relationship? Is there anything times 9 that will give you 540? Well, I know 9 times 6 is 54. So wouldn't 9 times 60 be 540? Yeah, so 9 times 60. We're going to take 2 and times that by 60. 2 times 60, what is that going to give us? X is going to equal $120. That got a little sloppy there. So $120. Every week when she's making $540, $120 is going into savings. Let's look at the next problem. Problem 5. Marin's car, go ahead and take the E off, not care, uses 15 gallons of gas to travel 180 miles. If she has 2 gallons of gas left in the tank, how much more gas will she need to drive 320 miles? What are we being asked to find in this problem? How much more gas? So that's going to be referring to gallons she'll need to drive 320 miles. So let's answer that. She will need blank more gallons of gas to drive 320 miles. Let's go line by line, look for some key operation words, phrases, important numbers, what's being related to what. Marin's car uses 15 gallons of gas to travel 180 miles. Gallons is being related to miles there. If she has 2 gallons of gas left in the tank, how much more gas will she need to drive 320 miles? So we know that there are 2 gallons left. We need to figure out how much more gas she'll need to drive 320 miles. So here is my variable. Let's let X represent. Gas is going to be filled in gallons. This is feeling like a two-step problem. We are relating gallons to miles. So when we know that she can go 180 miles and use 15 gallons. Her total miles she has to drive is 320. So let's figure out how many gallons are needed for the total trip. Do you see a horizontal relationship? Do you see how you're going from 180 to 320? Do you see a vertical relationship, how you're going from 15 to 180 or 180 to 15? Well, let's see, is there anything times 15 that gives me 180? Let's check. So we go 180 divided by 15. There is 12. Maybe you didn't see that relationship, but I just checked it. So from here to here, I would be timesing by 12. So if I want to figure out the top value, I'm going to go from here to here, which means I would do the inverse of that. I would divide by 12. So 320 divided by 12, that gives me 26 and 6/10 repeating. So 6/10 repeating is 2/3. Is that my answer? No, this right here, remember the 320 miles is the total distance that she's going. We know that she has 2 gallons left in her tank. So if she has 2 gallons left in her tank, she needs to use this many gallons for 320, but she already has 2 in her tank, so she's not going to end up filling up with this much. What math do I need to do? Well, how much more in my question there? That tells me to subtract. So I'm going to take 26 and 6/10 repeating, and I'm going to subtract the 2 gallons of gas that I already have in the tank. So 26 and 6/10 repeating, we're going to subtract 2. That would leave us with 24 and 6/10 repeating more gallons of gas to drive the 320 miles. So this was a 2-part problem, wasn't it? Paying attention to that, how much more it told me that I needed to subtract. She has this left, but this is the total gallons that her car is going to require to go the 320 miles. So we had to subtract to figure out the final answer for this problem. Okay. Let's go ahead and let's do one more example of using proportions to solve problems. Jana has a beautiful flower garden. For every 3 tulips she plants 5 daisies. If Jana had a total of 40 flowers in her garden, how many tulips are there? What are we being asked to find in this problem? How many tulips are there? So let's answer that. There are blank tulips in her garden. Let's go line by line and look for those relationship key operation words. Jana has a beautiful flower garden. For every 3 tulips she plants 5 daisies. If Jana has a total of 40 flowers in her garden, how many tulips are there? So here's my variable, right? So we want to know how many tulips there are to daisies? No, in her garden. So tulips to really flowers. Flowers. So we know that there are 3 tulips, but do we know how many flowers? Well, let's look at this first relationship. We have 3 tulips for every 5 daisies. Right here, how many flowers are we talking about? This is a part to part. 3 tulips, 5 daisies. That's 8 flowers, right? 3 plus 5, that's 8. So we know that when there are 3 tulips, there are 8 total flowers. If her whole garden has 40 flowers, how many tulips are there? Do you see a horizontal relationship? Yeah, 8 times 5 is 40. So 3 times 5 would be 15. So there are 15 tulips in her garden. The tricky thing with this problem is you're given a part to part, but your answer is looking for a part to total. So we had to change our part to part to be a part to total. And if you think about that, if you have 3 tulips for every 5 daisies, then you have 3 tulips for every 8 flowers, because the 3 plus 5 gives us the total flowers they're talking about in that ratio.